Welcome to a brief video presentation of the Fancort Flex, a universal SMD lead forming and cutting system that processes two sides of a package at one time to produce a gull-wing footprint. What we will see in this video is a standard flex with automatic standoff control, dimension A in this drawing. Form and trim systems offered by Fancort and is the only one that processes two sides. The other universal systems process one side at a time. The Flex is recommended for higher and more accurate production requirements, less part handling, and tighter tolerance on the tip-to-tip dimension D in this drawing. Let's look at an overview of the Flex. Of the tooling where the forming and cutting actions occur, the press, which drives the tool and is referred to as the floating anvil press because it automatically controls standoff height, which is the gap between the package bottom and the board, the part loader, and centering station. The system is available with inch or metric versions, and the power supply can be 110 or 220 volts. Now let's look at the tooling in some detail. This model Flex can process packages up to 2 inches in length. There are two precision die members that are connected and are moved on a precision lead screw to set the final cutting length, or what we refer to as tip-to-tip dimension, which once set can be locked in place. The display on the digital scale is used by the operator to set this dimension. The final cutting dimension is dictated by the customer's desired footprint, which is dimension D on our drawing. Has a set of die members consisting of a pressure pad that clamps the leads during forming and cutting to prevent stress. Upper and lower forming members, and floating anvils that set the shoulder dimension B in our drawing. The anvils can be easily changed to accommodate different forming specifications, such as a smaller shoulder length, dimension B, and shoulder radius, dimension G. Sliding in and out. The formers are made to a specific dimension to allow clearance for the material thickness of the component's leads, dimension C in our drawing. The other critical parts of the tool are the cutting members consisting of a fixed size specified by the customer as dimension X on our drawing. Or specify the standard JEDEC dimension of 0.025 inches. The upper and lower cutters and formers will need to be changed if the foot length is changed. The Flex can be set to provide a toe-up or toe-down configuration based on the customer's requirement. The centering stage and loader are designed to make it easy for the operator to load parts into and out of the tool. The centering stage moves like an iris on a camera. And locates the body of the package. This ensures that when the operator uses the vacuum-powered loader to pick up the part, it is loaded precisely in the center of the flex tool. This provides uniformity to the finished forming and cutting dimensions. Once the package has been located in the centering station and the jaws are not locking the package, it is ready to be moved into the tool using the vacuum and handle. The operator uses the toggle switch to engage the vacuum, picks up the part, and feeds directly into the tool, which has already been set the proper cut length and has the correct inserts. If a two-sided package is used, this requires only one operation. If a quad pack is being processed, the operator removes the part from the tool into the centering station, rotates the centering station, and repeats the loading and press cycle. If the package should have metal or ceramic tie bars, these need to be removed before processing in the flex by using a Fancort lead cutter. Finally, we have the floating anvil press. Fancort received a patent for this technology a number of years ago in response to a need by our customers to accurately control standoff height on ceramic and metal case surface mount devices. These types of packages are inconsistent in body thickness, some as much as plus or minus 20 thousandths of an inch. And the lead exit position can also vary. If the body thickness or lead exit position varies, it is impossible to maintain a consistent standoff height unless the operator adjusts the forming anvils each time a package is formed. This would require a manual standoff machine and constant measuring of the part and resetting the tool before processing. With the floating anvil system, this is done automatically. In other words, A is maintained regardless of J. An electromechanical control system under the press moves the lower forming anvils down while the tool is forming the leads. A pin located in the tool is controlled by this mechanism, and as the tool closes, the formers and the anvils start to move down until the bottom of the package contacts the pin, which locks the anvils in place to complete the forming cycle. Now that we've seen an overview of the flex, let's process a fine-pitch lead FPGA that has had its non-conductive tie bars removed. This can be done with a hand cutter or a Fancort excise tool. That completes this brief look at the flex with automatic standoff control. It is one of the many tools, systems, and services offered by Fancort, including dedicated tools for higher production and more precise control of tolerances. These tools and services can all be found on the Fancort website at www.fancort.com. For additional information and to discuss your specific applications, contact Robert Antonelli at 1-888-FANCORT or by email at robertantonelli@fancort.com.